Okay, I think we can get started now. Um, um, Hi, Shantanu sir.
I'm good. Hi, everyone. Hey,
I
man.
think, yeah, yeah.
Yeah,
I remember when I used to join 2 years back. Then, yeah,
yeah. I was free and up, so I thought, like, well, let's join.
yeah.
That's great.
So we can get started. Let me share my screen. So I didn't get the time to prepare a presentation, so I will run by using the book only today. Yeah. So today's chapter is around inference optimization. So basically, this chapter focuses on making the model faster and cheaper. Now, when we say inference optimization, inference means once model training is done, how are you interacting with the model, right? Getting output out of the training model. Okay. Now, inference can be done at multiple level. You can do at model level, you can do hardware level, and you can do at the service level. Okay. What model level means? You change the model architecture, right? Just say we all know कि transformer has a issue on the output side. The architecture generate the decoder generate the token sequentially. It cannot generate tokens parallelly, right? So there's an architectural issue in transformer model. That's why inference is a very costly in general. हार्डवेयर कि आपका हार्डवेयर कितना सपोर्ट कर रहा है इन टर्म्स ऑफ मेमोरी और इन टर्म्स ऑफ बैंडविड्थ व्हेन आई से बैंडविड्थ डेटा ट्रांसफर स्पीड ठीक है सर्विस लेवल यू कैन से मोर अराउंड द नेटवर्क राइट ओके कि हाउ मच रिक्वेस्ट इट इज एबल टू प्रोसेस इन अ सर्टेन टाइम पीरियड और ट्रैफिक पैटर्न राइट तो ओके so now going forward yeah. So now it's not like you can optimize for everything, right? You can optimize for latency, but it might lead to higher cost. You can optimize for hardware that it can have more computing power. Again, it can have a higher cost. If you want to reduce the just the inference cost, maybe instead of online processing, you might have to do batch where it takes more time, but cost will go down two, three times, right? Okay. So now understanding inference optimization, we have like I mentioned, right? So there are two distinct phases in AI model lifecycle. One is training and one is inference. Training refers to process of building a model, and inference refers to process of using a model to compute a output. Okay. So because we are not as a user, all of us are not going to train or fine tune a model in general. Okay, we are mostly going to use a hosted service in our own premise or a cloud based provider. So we are mostly want to understand what are the things which impact the inference part. Okay, so after that we have inference overview. So in production, a component that runs model inference is called inference server. Okay. So I will jump to the image. It will be more clear. So just say this is your inference server, right? So you send a request to the inference server and you receive the response back. Basically, just say you are interacting with Chat GPT. Chat GPT, you are sending a question to Chat GPT. It where model resides, and this is the hardware, right? So that's what is called inference server. This part, this component, entire component, where the model is hosted, is called inference server. Now, so model APIs like those provided by OpenAI, Google's are inference services. Okay, so if you are using APIs provided by OpenAI or Google, we are not going to implement any of one of them. Just say we are building our application using ChatGPT API, like OpenAI API or Gemini or Gemini. So we might not need it. Just say you are hosting Llama, because Llama is open source. Then you might need to do all these optimization. Okay. तो व्हेन वी डू द इन्फरेंस तो उसमें बॉटलनेक्स क्या क्या आ सकते हैं, ठीक है? तो देयर आर टू मेन टाइप्स ऑफ बॉटलनेक. ओके. So optimization, inference optimization is about identifying the bottleneck and addressing them. ठीक है, तो इसमें एक एग्जांपल है, जैसे इन फॉर एग्जांपल बैंगलोर का लेते हैं, राइट? ठीक है. तो इफ यू वांट टू ऑप्टिमाइज फॉर द ट्रैफिक, यू विल प्लान की रोड कितनी चौड़ी होनी चाहिए, एक्सेस पॉइंट कहाँ कहाँ पे होने चाहिए, फ्लाईओवर कहाँ पे बिल्ड करना है. दिस इज सिमिलर टू दैट. ठीक है. तो देयर आर टू मेन टाइप्स ऑफ bottleneck in this. One is called compute bound. ठीक है. uh, bound, in simple term, complexity, right? It's like आप एडिशन कर रहे हो, या you are you solving for a matrix, ठीक है, or are you trying to compute a complex mathematical equation. So what it means is compute bound is कि आपके पास कितने flops available है per second. Flop like how many operation you can execute per second. ठीक है. तो अगर आपका कंप्यूट पावर कम है, या नंबर ऑफ ऑपरेशन यू कैन एग्जीक्यूट पर सेकेंड इज लो, so that application is called compute bound in that case. And then second type is memory bandwidth bound. ठीक है. So memory bandwidth bound is around data transfer rate. ठीक है. Just say you have data in your CPU memory and training model on a GPU. Because we are training model on a GPU, it means we need to transfer the data even in batches from CPU to GPU, right? Okay. How much this time takes, right, to transfer the data from one CPU to GPU is what we call memory bandwidth bound here. ठीक है. So now in memory bandwidth bound, some people think that out of memory error, we all have got this error when we have ran the code, right? ठीक है. So out of memory error is also your in general terminology, people might think that it's a memory bound error, but it's not in general. ठीक है. So that's what memory bound is also used by some people to refer to the task whose time to complete is constrained by the memory capacity rather than memory bandwidth. So memory bandwidth is related to data transfer speed, and memory capacity is related to how much memory you have, right? Okay, so that's why we are mentioning that out of memory error. That's what we in general we all identify with, right? Okay, so this situation can often be mitigated by splitting your task into smaller pieces. So just say if we are constrained by GPU memory. So just for reference context, right? GPU memory, just say our laptop, right? Uh, a good laptop in like personal laptop has 16 GB of memory, or a good business laptop what we use for office use is like 32 GB or 64 GB. So CPU, all our laptop, most of us use CPU, right? So has a higher memory in general. GPU has a lower memory in general. Okay. As you go further, more efficient chips, they will even have a lower memory. Okay. So because we cannot fit entire model into GPU, okay, we can split the model across GPU memory and CPU memory. Okay. So this splitting will slow down the computation. Okay. So because of time it takes to transfer the data between CPU and GPU. Okay. So if data transfer is fast enough, this become doesn't less of a issue. So even though you have a less memory, you can transfer the memory from you have a less memory in GPU. You can transfer the data from CPU to GPU and do the computation. Again, what matters here is how fast you are able to transfer. If you are able to transfer it fast, memory capacity limitation doesn't matter. So again, it's a bandwidth bound issue at the end of the day. Okay. So there's a something called a roofline plot. Okay. So this was introduced by a paper in 2009. So which help us in classifying that an operation that we are running is whether memory bound or compute bound. Okay. So it's a and so here it's based on arithmetic intensity, which is a number of arithmetic operation per byte of the memory access. Okay, so we have some profiling tool like NVIDIA Insight, which will show the roofline chart to tell you whether your workload is compute bound or memory bound. Okay, I will go to the chart now. Sorry. Um, hmm, One moment, I'm just trying to adjust. Okay. So again, like I mentioned, right, compute bound is around the number of operations you are able to perform per second. Okay. So अगर आपको compute bound problem solve करनी, you can have more chips, right? Or you can have simple one chip with which has more compute power. Okay. Bandwidth bound workload might be sped up by leveraging chips with higher bandwidth, where data transfer speed is higher. But again, it all comes down to cost, right? Where you optimize for the cost and what you and time here. Okay. So this is a roofline plot I was talking about, which is one of the industry standard to decide whether a operation we are running is memory bound or compute bound. So just to explain the plot here, on the x-axis you have arithmetic intensity कि कितना ज़्यादा operations हम perform कर रहे हैं, and on the y-axis we have performance flops, basically how much we can perform. ठीक है. So just say after this green area is a compute bound reason. Why? I will explain. So just say here till here, right? You have one-to-one correspondence. ठीक है. Till up once this arithmetic intensity increases, और आपका chip can just perform this much. Okay. uh, your chip has this much. Once it hits this, right, it can perform just say 100 flops per second. Oh, this is in log actually. This is not actually 100. This is log, so that's why it looks so low. Okay, so once your compute intensity hits this, after that, even if you have a lot more this, right, you want to perform more operation per second, because but your chip won't allow you, so you enter the compute bound region here. Okay, before that, it's not about the arithmetic intensity, it's not about how much uh, operation you can perform. It's in this region, it's more about uh, how fast you can transfer the data between the chips here. So if you use NVIDIA Insight or some similar tool, and if this dot indicate where your operation lies, okay. So accordingly, you can decide what to optimize for. If your application lies here, which is in memory bound region, it means that you might have to bring in chips which have a higher data transfer speed. uh, but if it goes here again, it's like bringing a chip, like instead of just NVIDIA A100, you want to bring NVIDIA H100, which is much faster in general. Okay. So I will go down. Uh, so if you all recall, right, from chapter 2, like, which was related on transformer, right? तो ट्रांसफॉर्मर में दो प्रोसेस होते हैं. One is prefill and decode. Like if you have to summarize it very high level, right? Prefill is more like uh, uh, and please note this is related to uh, इन्फरेंस ओनली, आई एम नॉट टॉकिंग अबाउट ट्रेनिंग एट ऑल. ओके. तो जैसे हमने एक चैट जीपीटी को एक क्वेरी भेजा, ठीक है, तो क्वेरी भेजने पे दैट्स इनपुट, ठीक है. तो इनपुट टोकन्स आर प्रोसेस्ड इन पैरेलल. ओके. So, how many token can be processed at once is limited by number of operation, because we are processing in parallel and number of operation we are performing. Pre-filling process is considered compute bound. Okay. Now comes the main what you say monster in the room, decoding, right? Decoding is what currently limits what we can do with AI, to be honest. Okay. The transformer architecture which we are using across all the application, they all use transformer, and problem with all the architecture is that they generate one output token at a time. Okay. Like next level of revolution which can happen in AI comes from this architecture perspective. Right now, there's no alternative of transformer currently. Once this breakthrough comes, I think we might see even a better application. And so, yeah. So decoding is like what decoding is, right? You are loading the model matrix into GPU, okay, which is limited by how quickly your data can load data into memory. Okay. So decoding is therefore memory bandwidth bound. Okay. So now, so there are two steps when you send a query to ChatGPT or Gemini. One is processing in parallel, another is decoding those, getting the output. Okay. So these, because there are two steps in inference itself, they both require different optimization techniques itself. Okay. So there's a image also. Yeah. So if you look at this image, right? Who wrote the book Chaos? So you have prefill. This is a compound bound, compute bound, because it's a working parallel. But output James Gleek did, full stop. Okay, and end of sentence, which is a first James get generated. Okay, then using the attention mechanism, right, and the previous context, it will generate Gleek. So it's a generating one by one. That's why it's a memory bandwidth. Right. Okay. So like I mentioned, because prefill and decoder have a different computational profile, they are often decoupled in production with separate machines. Uh, Here. Okay. So because the hardware requirement itself is different for both of them. Right. Okay. So in terms of LLM context, so we care about the context length, right? Okay. Context length is, we all know, it's like how much information we are passing. Like, just say if I'm talking to ChatGPT, I can ask, summarize this PDF, and I upload a 500-page PDF, which is a very long context length. I can upload just 2-page PDF, which is a small context length, right? Okay, because the longer context, and it means it's a memory bandwidth bound problem. Okay, so yeah, so like I mentioned, due to prevalence of transformer architecture and limitation of existing accelerator technology, many AI and data workload are memory bandwidth bound. So again, just to explain it, right? When we say why AI and data workload are memory bandwidth bound is simply because of this decoder part, right? Because it's working in a sequential manner, generating output one at a time. Okay. So once maybe this we come across some better architecture, it might become a compute bound down the line, where it's limited by the innovation that's happening in the hardware side, right? Currently, we are limited by the algorithmic side as of today. So then we have online and batch insurance API. So online API is which we all use on a daily basis now, is like GPT and all. Batch API is I think very few of us uses in general, but they might be using at the enterprise level, right. So if you are using the batch API, it's optimized for the cost, because you are not worried about the latency. You can just say you want to summarize something, you want to summarize all the conversations which happened in a day. This process will run in the night, taking its time. It will run on a cheaper GPUs, right? Just instead of 1 minute, it will take 30 minutes to do that process, but it will be optimized for the cost. Okay, so now depends where do you want to use the online APIs versus batch APIs, right? So just say real-time interaction, consumer chatbots, and all, right? There we have to use the online API itself, right? Okay, but just say you need to generate a report at the end of the day, and what are the conversation or meeting notes and all happened. You can use the batch API. Okay. Yeah. So depends on what your use case, and accordingly you can decide whether to go for a batch API or you can go for a online API, right? So yeah. Now in that context of online and batch API, okay. Uh, so if you remember when you talk to GPT or Gemini, right? They don't. If you have a very large question, right? Like if you ask a small question, it you will see the all the output at one go. Okay, but your question is complex, right? You might see that it is still generating. Okay, it takes 5-10 seconds to get the complete response because what we call auto regressive decoder. Because like we all mentioned multiple times, right? That it's a decoding one by one. Okay, so many online API offer streaming mode. Streaming mode is nothing but कि जैसे ही डिकोड हो रहा है उसी टाइम पे आपको आउटपुट आ गया, ठीक है, बट इट्स नॉट कंप्लीटेड. ओके, तो दिस रिड्यूसेस द टाइम यूजर हैव टू वेट अंटिल द फर्स्ट टोकन. ठीक है, देयर देयर टू थिंग. टाइम फर्स्ट टोकन जनरेट करने में कितना टाइम लग रहा है, ठीक है, दैट्स ऑन द सिस्टम साइड. ओके यार, जहां पे इन्फरेंस हो रहा है आपको फर्स्ट टोकन कब दिख रहा है, दैट्स ऑन द यूजर साइड. यू कैन डू इट टू वे, कि जब पूरा रिस्पॉन्स आ जाए तब आपको दिखाते हैं. ठीक है. सेकेंड इज कि एज सुन एज इट इज जनरेटिंग आपको तुरंत रिस्पॉन्स दिखाना स्टार्ट कर देते हैं. दोनों के प्रोज एंड कॉन्स हैं. एक जैसे कि अब मान लो कि आपने जीपीटी को क्वेश्चन पूछा, जीपीटी आंसर जनरेट कर रहा है, सोचे जा रहा है, और इट टेक जैसे इट इज टेकिंग 20 सेकेंड टू जनरेट. We might lose that attention in 20 second and move on to the next application और कुछ और करने लगेंगे. ठीक है, तो इससे at the end of the day it's a loss of business for chat GPT, right? So you want to ensure that user this is optimized for in both way, right? That you are giving response in a real time, but at the same time, it's not. It doesn't look too much incomplete. So हो सकता है you are bunching together 20-30% of token, then start showing it to the customer. ठीक है. अब स्ट्रीमिंग मोड की प्रॉब्लम क्या है, ठीक है. मान लो कि आपने एक ऐप चैटबॉट बिल्ड किया था कस्टमर केयर के लिए, और यू वेंट विथ स्ट्रीमिंग मोड टू ऑप्टिमाइज सो दैट कस्टमर गेट फास्टर रिस्पॉन्स. बट जस्ट से वन ऑफ योर गार्ड रेल्स फेल्स, राइट? ठीक है. And when I say guardrail fails and user get a wrong response, or just say it has some bias or some sort of thing, right? Which you built on the top of your output. If only if output seems good enough, then only show it to the user. But if you work in the streaming mode, you might not be able to do that. Okay. व्हाट माइट हैपन दैट कि आपने स्ट्रीमिंग मोड में डाल दिया, आपका आउटपुट आ गया, फिर आपका एआई एज अ जज व्हाट यू कॉल इज इवैल्यूएटिंग द आउटपुट, बोला कि नहीं अब तो खराब है, इट विल डिसअपीयर दैट मैसेज, बट यूजर माइट हैव ऑलरेडी सीन व्हाट यू जनरेटेड, राइट? ओके. ओके, मूविंग ऑन. ठीक है. तो या there's a one more point they are making here is कि in terms of AI and in terms of traditional ML, online inference and batch inference mean different things. ठीक है. In terms of traditional ML, online inference means that prediction are computed after request have arrived. कि आपने एक API कॉल की, आपको आपने सारे वेरिएबल पास किए, मॉडल रियल टाइम पे प्रिडिक्शन कर रहा है. ठीक है. बैच इंफरेंस का मतलब इसमें हुआ कि आपको ने पहले से फोरकास्टिंग कर रखी है या प्रिडिक्शन कर रखा है आपने बस बोला कि इसके बारे में बता दो, उसने डेटा उठाया और दे दिया. नो कंप्यूटेशन इज हैपनिंग एट रियल टाइम. ठीक है. Okay. Sorry, I've been talking for long. Any question or anything before we go ahead, or I can continue? Yes sir. Correct. Chat GPT और Gemini दोनों streaming ही कर रहे हैं. Right. हाँ सर, मतलब इवन टुडे लाइक आई यूज जीपीटी फॉर coding a lot, right? But most of the time I do get wrong responses and all. I can't talk about biases and all because I don't do those kind of query. But yeah, obviously that's a drawback there.
Mm, you're talking about the transformer model, right? As far as I understand, that DeepSeek, uh, they don't need GPUs. I don't know if it is right or wrong. Does it mean they don't use transformer model?
No, sir. See, transform. If I'm right, DeepSeek has been built something called chain of thought. Their algorithm
Mhm.
underlying a transformer model itself. Architecture is on transformer model, but the way they do the computation is very different. Mixture of expert. Sorry, it's called MOE. Right? Okay. They have multiple, smaller model, and they see what which two output from which two to combine, and the rest of the CPU or GPU will be idle. It speed up the training process and all. Okay, but architecture is still transformer only. Any model you see in the market today is all around a transformer.
Otherwise, it will be too slow, right?
Sorry.
Otherwise, it will be too slow. Without, because transformer model does the parallel processing, right?
A transformer depends. Where are we talking about, sir? Like we just discussed, right? Ki input token is parallel, but output is sequential.
Mm-hmm. Okay. So yeah, because I was understanding that GPU is just good for that parallel. That is why it is getting faster on the, and they are using. I don't know how they are doing then. Maybe
They are using
they are not
GPU.
relying on GPU. Then I
Yeah,
guess.
they are using GPU. I can just quickly Google it. Mm.
Yeah, I think DeepSeek also uses GPU. It's just that they don't use the state of the art, best in class.
Mm. So
No,
yeah, they
they
are
use
using
older ones.
A100 and H100 only. Yeah.
So, मतलब जो भी latest, I don't know what is the latest available by NVIDIA or anyone, but they used older class of
Oh, okay.
GPUs with
So
some constrained
yeah,
resources.
if I remember it right, तो यूएस ने जो भी मतलब रिस्ट्रिक्शन लगाए थे, तो दे couldn't मतलब because they are based out of China, so
Mm-hmm.
उनको लेटेस्ट चिप्स नहीं मिल पाए, तो they were using older NVIDIA GPUs
Okay. Okay.
for training.
Cool. Thank you.
Yeah. Okay. Now we are moving on to inference performance metrics. ठीक है कि how do we what are the metrics to measure the inference performance? Uh, ठीक है. तो one is latency. Latency we all are aware of कि कितना time लग रहा है to generate output, right? ठीक है. अब latency is a very what you can ambiguous term, right? You have to be very precise when you are defining a metric. ठीक है, because latency can mean multiple thing, right? तो इसमें एक आता है टाइम टू द फर्स्ट टोकन. आपका पहला टोकन जनरेट होने में कितना टाइम लगा. ठीक है, तो इसमें मेनली इट्स रिलेटेड टू प्री फिल स्टेप. तो प्री फिलिंग मतलब इनपुट टोकन कितनी देर में प्रोसेस हुआ है. ठीक है, तो आपका इनपुट कितना लॉन्ग लॉन्ग है, आपका कंटेक्स्ट कितना लॉन्ग है, that defines time to the first token. ठीक है. Uh, okay. So now, same thing which I was mentioning earlier, user might have different expectation for uh, time to the first token. So for a conversational chatbot, TTFT should be instantaneous, right? ठीक है. But आप summarization कर रहे हो and user knows it might take time, so he is willing to wait long. Second is time per output token. ठीक है. TPOT measures how quickly its output token is generated after the first token. ठीक है कि आपका पहला टोकन तो आ गया आउटपुट का, उसके बाद टोटल इन जनरल कितना टाइम लग रहा है. ठीक है. एंड देन यू हैव टाइम बिटवीन द टोकन. दो आउटपुट टोकन के बीच कितना टाइम लग रहा है. तो टोटल लैटेंसी इन जनरल फॉर अ मॉडल इज टाइम टू द फर्स्ट टोकन, देन टाइम पर आउटपुट टोकन में कितना लग रहा है, और दो कितने आपके आउटपुट टोकन है. ठीक है. मतलब बेसिकली आपका रिस्पॉन्स कितना लंबा है. तो दिस इज अ टोटल. ठीक है. बट अगेन द कन्वर्जेशन विच वी वर हैविंग है, दो एप्लीकेशन जिनकी सेम लैटेंसी है, they can offer different user experience because how do you show output to the user. आप सारा सबसे बाद में दिखा रहे हो या पहले टोकन दिखा रहे हो, पहले टोकन ऑनवर्ड ही दिखा रहे हो, राइट. तो अकॉर्डिंगली यूजर एक्सपीरियंस विल डिफर. ठीक है. Another thing is, it's important to note that TTFT and TPOT values observed by user might differ from those observed by the model. Okay, especially in a scenario involving COT, chain of thoughts, right, or agentic query, where model generate intermediate step not shown to the user. ठीक है. So that's why some team uses metric called time to publish यहाँ पर. Okay, to make it explicit that it measures the time first taken that user sees. Okay, what it means is कि एक एग्जांपल दिया, I will rather read it's easier to understand. ठीक है. आपने एक क्वेरी भेजा जैसे एंथ्रोपिक को. ठीक है. Anthropic uses some sort of chain of thoughts actually. So generate, so entropy क्या करेगा, it will generate a plan, it will consist of sequence of action. This plan is not shown to user. ठीक है. Take action and log their output. Output is also not shown to user. Based on the output, generate a final response to the user. Now, as per the model, पहला टोकन कब जनरेट हुआ, जब आपने प्लान जनरेट किया. बस as per the user, पहला टोकन कब जनरेट हुआ, when user you generated the final response. So in terms of a machine and in terms of a user, both are different things. तभी we are using a metric called time to publish, की which is more relevant to humans, right, कि हम कब पहला टोकन देखते हैं. ठीक है. Okay, another thing is कि latency is a distribution, so we should not be taking average over latency. Okay, because obviously there might be network related issue or somewhere machine thinking a lot of time. So if you average it out, it will be prone to the outliers. Okay, so always look at, maybe you can say percentile, right. Okay, कि 95% रिक्वेस्ट कितना टाइम ले रहा है या 99% रिक्वेस्ट कितना टाइम ले रहा है. तो ऑलवेज गुड टू थिंक latency in terms of a percentile rather than a average or of those short. Okay. Then there's a concept of throughput and goodput. So throughput is nothing but कि per second आपका कितना output token generate हो पा रहा है across all user and request, right? So throughput is usually typically measured in token per second, TPS they call it. ठीक है. So if you serve multiple users, token per user is also, token per second per user is also used to evaluate how the system scales with more user. ठीक है. अब request per second एक की एक है, because problem with request per second is it takes multiple seconds to generate output. So rather than looking at TPS, they are something saying we can use the RPM, request per minute. Okay, कि कितने रिक्वेस्ट पर मिनट कंप्लीट हो रहे हैं, rather than talking in terms of absolute token, we are talking in terms of the request. ठीक है. Okay. Okay. Now, throughput is directly linked to the compute cost. Okay, this is a bit of mathematics, but I will try to explain here. So please bear with me. ठीक है. तो जैसे आपका सिस्टम कॉस्ट इज $2 पर आवर. ठीक है. थ्रूपुट इज 100 टोकन पर सेकेंड. ठीक है. तो अगर आपका 100 टोकन पर सेकेंड है, ठीक है, एंड जैसे यू नीड टू जनरेट 1 मिलियन आउटपुट टोकन. ठीक है. तो कितना टाइम लगेगा? तो जैसे वन आवर हैज 60 minutes into 60 seconds, which is 3600, right? Okay. 3600 into 100 become 3.6 lakh, right? So cost of 3.6 lakh token is $2 almost. ठीक है. So cost of 1 million, which is almost 3 times, will be 3 times of $2, which is around $6 you see. Okay. So now just say each request generate 200 output per token on an average. So cost for decoding 1K request, right? Okay, will be $1.1. Okay, so this is again simple thing, right? 200 into 1K request, which is 200K, right? 200K is almost like 1 by 6 of 1 million. So 1 million का $6 था या $5.5 था. So for 200K, it will be 5.5 divided by 6 kind of. So it will be $1.1. Uh, okay. Then this is for the decoding. Then pre-fill cost की बात आती है. मान लीजिए सेम कॉस्ट है $2 पर आवर. ठीक है. एंड pre-fill can process 100 requests per minute. ठीक है. So if you can process 100 requests per minute, cost for 1K request will be 1 by 6 of it, right? Okay, so which is 1 by 6 of 2. So which is almost how much? So by 1 by 6, sorry, I didn't explain that, right? 100 requests per minute means 1K request को process करने में 10 minute लगेगा. 10 minute is how much? 1 by 6 of 2, right? 1 hour, correct? 1 by 6 of 1 hour, so 2 divided by 6, you get 0.33. So total cost for pre-filling and decoding is 1.1 plus 0.33, 1.44. Okay. Uh, ठीक है. And now what to consider good throughput is again depends upon the model. Smaller model and higher in chip typically result in higher throughput. Okay. And then, okay. Again, problem with throughput is for us, just the model size is similar. Okay. But how they define token is very different, right? Chat GPT token, like OpenAI token definition is different from Gemini token definition, right? So you cannot actually compare two model directly in terms of uh, token throughput. Yes, sir. Please go ahead.
Um, I mean, can we think of something like this? Let's say I have a query in ChatGPT, which I think like everybody uses. Where how what is the cost of like one conversation? Let's say I put in like what is the meaning of life, and it gives me like a paragraph. What would be the cost of that? To think in that terms. Let's
सर
say it's a
आप
100 word response, like tokens.
हाँ हाँ.
What
Okay.
what would be
Sir,
the cost?
सेम थिंग वी आर टॉकिंग अबाउट इट. जैसे यहाँ पे आपका जैसे आपका एक क्वेरी है. ठीक है. क्वेरी हैज 100 वर्ड. ओके. जैसे आपको 10 वर्ड मिलके एक 1 टोकन बनाते हैं, तो आपके इनपुट साइड 10 टोकन है. ठीक है. आपका जो आउटपुट आता है वो 500 वर्ड्स का आता है. 500 वर्ड बिकेम 50 टोकन. ठीक है. So we
Okay.
can just and you know this part, right? How much is taking in, what's the cost of decoding and what's the cost of pre-filling, right? तो आपने जो इनपुट तो आपने जब क्वेरी भेजा तो उसको टोकन में कन्वर्ट किया गया, तो उसकी कॉस्ट यहाँ से आ रही है. ठीक है. तो दिस इज जैसे 1 रिक्वेस्ट पर मिनट, और यू कैन से जैसे यू से 1 रिक्वेस्ट, योर व्हाट यू से entire query is 1 request, right?
Yeah.
ठीक है. तो 0.33 divided by 1000. ठीक
Okay.
है, दैट बिकम्स योर प्री फिलिंग कॉस्ट। यहाँ पे अम, ठीक है, फॉर डिकोडिंग 1K रिक्वेस्ट अगेन जस्ट एज्यूम सिमिलर नंबर्स। So 1K request का 1.11 है, so you divide by 100, 1000 again. So you will get for this 1.11 divided by 1000 and 0.33 divided by 1000. So you are getting these kind of cost.
Mhm. Sounds good. Thanks.
Okay. Any other question? So I will move forward यहाँ पे, ठीक है। So again, like I was mentioning, like batching can improve throughput but reduce okay, it can improve throughput, but I think this is a typo. Okay, this will increase latency. Okay, because it takes a lot of time. ठीक है। तो yeah, so according to LinkedIn AI team in their reflection after a year of deploy generating AI product, it's not uncommon to double or triple the throughput if you are willing to sacrifice TTFT and TPOT, basically latency. If you are willing to trade off, you can get higher throughput. That's why batch processing is cheaper because throughput is higher. Because if you look at the calculation above, right, it's all about the throughput. How many token you are able to generate per second, right? If you are able to generate more token per second, right, your compute cost is depending upon time you are using, right? Not how many tokens you are generating. Okay. So if you are able to generate higher to number of token, okay, then you will be able to reduce your cost. Okay. Uh, okay. Sorry. Okay. Sorry. I think I need to go next page. Throughput and good part. Um, hmm, ठीक है. So, due to this trade-off of throughput and latency, it can lead to bad user experience. It might lead to higher cost or more latency, right? ठीक है. So some team focuses on good put. ठीक है. It's a similar metric to throughput, but more business user friendly or what you say, right? ठीक है. So just say an application has a following objective. For each request that user makes, time to the first token should be almost 200 millisecond, and time, I forgot the full form, time between generating token, right? This is a word. Uh, should be at most 100 millisecond. ठीक है. And let's say your inference service can complete 100 requests per minute. Okay, जो capacity है. ठीक है. Out of 100 requests, only 30 satisfy the SLO, software level agreement, or SLA we call it, right, in our industry. So software level service level agreement. कि हमने जो 100 request किया, केवल 30 are meeting the criteria which were defined. So good put of this service is 30 requests per minute. ठीक है. So this is a representation of it. Doesn't convey much, but yeah, that out of 10 requests we made, and there are only 3 which are lying, in zone we wanted. So yeah. Uh, okay. Now we have utilization and FPU and MBU. ठीक है. Yeah. So utilization metrics, how efficiently a resource is being used. Okay. So it typically quantify the proportion of resources actually being used compared to total available capacity. ठीक है. So one metric that NVIDIA publishes, right, is GPU utilization. कि GPU utilization कितना है. But the author here arguing is it's a very misleading metric because NVIDIA just talks in terms of time utilization. ठीक है. मतलब कि मान लीजिए कि you have a GPU cluster for 10 hours, ठीक है, and processing was executed for 5 hours. ठीक है. तो NVIDIA will simply say that GPU utilization is 50%. Okay. But actively processing task doesn't mean doing so efficiently. Even if it ran for 5 hours, It doesn't mean it was doing it efficiently. Okay. Okay. So they're giving an example. Consider a tiny GPU capable of doing 100 operation per second. Okay. In NVIDIA's definition of utilization, this GPU can report 100% utilization because it's running all the time. Okay. Even though it's only doing one operation per second. Okay. Basically, this 100 operation means 100 flops. So it has the ability to do 100 flops, but it is doing one flop only because issue on the architecture side. Okay, this is not issue of hardware. If you are not able to utilize, it's not hardware's issue, right? It's a architectural issue. Okay, so just you are doing only one operation per second. Okay, so you can say actually utilization is just 1%. Okay, so if you pay for a machine that can do 100 operation and use it for only one operation, you are wasting your machine. Uh, okay, so NVIDIA's optimization metric is not very useful metric. Okay, so a utilization metric we might care about out of all operation a machine is capable of computing. Okay, how many it is doing in a given time. Basically, how many flops of operation, if just say a machine can perform 1 trillion flops of operation per second, but you are only executing 1 billion flops per second, right? That's what relevant to us, and this metric is called MFU, model flop utilization. Okay, okay. So this is nothing but ratio of observed throughput relative to theoretical maximum throughput. तो आपने जैसे बोला कि H100 can perform 1 million per second, but you are only running just say because of your decoder is doing sequentially, right? Because of sequential manner, decoder doesn't require a lot of compute. Problem is it's doing it sequentially. Okay, so even though you have a lot of flop available, okay, uh, it's not being efficient to utilize. Okay. Sorry, someone is saying something. Okay. So also another thing is right memory bandwidth, right? This is also expensive hardware, right? So you want to know how hardware bandwidth is utilized. So there's two metrics: MFP, model flow, and which measures the hardware utilization or compute side. You can relate it with compute side of thing. And MBU is related to memory side of thing, right? If just a peak bandwidth is 1 TB per second, basically how much data you can transfer 1 TB per second, but you are only transferring 1200 GB per second, your MBU is 50%. Okay. So then memory bandwidth calculation, right? How much is the parameter count into byte per param into number of token per second. Okay. So just say your model is 7 billion parameter model in FP16, basically single precision or 2 byte. Okay, so 7 billion into 2 byte and it can achieve 100 token per second, right? So 100 you multiply, so it requires 700 GB per second uh, of memory band. Okay, MB, and just say you have a 1 TB, so your utilization is 70%. Okay, so that's where there's a process of quantization which हमने पहले discuss किया था कि जैसे इंस्टेड ऑफ FP16 यूज FP8, करेक्ट? ओके, तो यहाँ पे 2 बाइट की जगह 1 बाइट हो जाएगा, राइट? ओके, so this will go to 350 GB. It will become half. Okay. Yeah. Okay. Sorry, one. Let me go back. So like मैंने तो यहाँ पे utilization 70% था, तो I'm not getting into this. So yeah, now what to consider a good MFU compute side and MBU the memory side depends upon the hardware and the workload, right? So compute bound workload are typically have higher MFU. बेसिकली मतलब क्या है कि आपको जहाँ पे कंप्यूट करना है, राइट, जैसे ट्रेनिंग, ठीक है, और जैसे आपका प्री फिलिंग, राइट, वहां पे यू हैव मोर कंप्यूट बाइंड वर्कलोड, तो यू नीड हायर एमएफयू बट लोअर एमबीयू, ठीक है। बैंडविड्थ बाउंड वर्कलोड विच इज मोर ऑफ अ डिकोडिंग, वहां पे आपको लोअर एमएफयू चल जाएगा बट यू नीड हायर एमबीयू, ओके। तो इसीलिए chaining can between from more efficient optimization. Okay, and MFQ for training is typically higher than MFQ for inference. Okay, so इसीलिए what they do actually is for training and inference they use different hardware. They are अगर आप if you read about any model, right, they will tell they trained the model on this GPU, but they are doing inference on this GPU. Okay, because kind of resources required are different. Okay, even on the inference side they are using different hardware for pre-filling and different hardware for the decoding. Okay, so यहाँ पे they have a table, right, for different model what's their flop utilization. Okay, so this is palm has very high because this was one of the algorithm they applied to achieve higher MFU. I'm not sure what it is, but yeah. So you can see GPT has a very low utilization, and there's some other model, okay, with higher parameter. But basically, if you see, number of parameter also matters. So higher parameters, you can utilize better flops. If you are training it on one same hardware. Okay. Okay. Hardware is also mentioned here. Okay, which hardware they are using on this particular. So it's not actually comparable because of different hardware. Where so, but yeah. Mm. Now here they have one thing, right? Llama model के लिए bandwidth utilization कितना है? Depending upon number of concurrent user and they if they do it on the different chips. Alright. So here if you see the blue one is typically highest, but it is a very high cost. Okay, but red one similarly green one. So green one is the cheapest one. Red one is slightly better. So higher is better. So you are getting yeah. Please go ahead. Uh, like key points are covered in this book. I think rest is related to CPU and GPU. So we can do self read. If not, I can cover in next chapter.
Yeah, this still sounds good.
What are the
Some,
options? Means what are the other books that we want to learn? Any list?
I mean, even next book, is it again related to AI or something else? We are switching.
We can we
What
can
about security?
do
Security.
something on agentic architecture because agentic architecture is both system design, 80-90% plus AI as well, probably.
Yeah, that's a good thought actually, and that's being widely used nowadays.
So is there any stuff blog material available for the agentic?
I can look for something. If I can find something, I will share in the group and maybe we can decide then if you want to go ahead with that.
Hmm. We can discuss this in the chat room, right? Oh, WhatsApp me. What will be the next thing we can discuss, right? Nah.
इसमें इसमें एक ग्रुप हम लोगों ने और स्टार्ट किया था, राइट? सिक्योरिटी के लिए, साइबर सिक्योरिटी के लिए। तो उसमें भी कुछ क्लासेस चल रही हैं क्या अलग से?
I don't think so.
नो सर।
Oh, Sham है here.
तो उसके लिए मैं चाह रहा था कि मतलब कि CISSP वाला सर्टिफिकेट है, उसकी बुक होती है अगर, लेकिन अब मुझे पता नहीं उसमें कितने लोग इंटरेस्ट होंगे, क्योंकि मेरे को तो करना है, सोचता हूँ करूँगा, लेकिन अब ये जब तक यही चल रहा है तो वो इस पर टाइम नहीं दे पाते हैं। बट अगर आपको बॉली बुक पढ़नी है तो देन वी कैन गो फॉर इट।
बुक का पीडीएफ है क्या, कि वो बुक क्या है, तो अमेजन पे है क्या?
या पीडीएफ मिल जाएगा सर, मैं डाउनलोड कर दूंगा पीडीएफ उसकी सर।
ठीक
उसका
है,
ये
अगर पीडीएफ
जो
है तो शुरू करो, उसके टॉपिक्स देखते हैं।
ओके।
तो वो भी एक अच्छा आइडिया हो सकता है, क्योंकि आई थिंक कि इसमें जो बुक हम लोगों ने कवर कर रहे हैं, इसमें अराउंड कितने पेजेस हैं? 1000 पेजेस के ऊपर ही है ना इसमें। अराउंड 1100 पेजेस हैं, एंड देयर आर 10 चैप्टर्स, एंड वी हैव रीच्ड टिल 9 चैप्टर। तो पूरी बुक खत्म करते हैं उन्होंने एक तरीके से वाली। तो अगर सिक्योरिटी वाली भी अच्छी बुक है, एंड बिकॉज सिक्योरिटी एंड दिस एआई आर always
सर
in
एक
demand.
Hmm. Mm,
ठीक है, मेरे ख्याल से आप जो बुक शेयर कर दो अंकुर जी, आप मेरे ख्याल से एजेंटिक वाला जो जरिए है उसको
There's a lot of echo.
echo हो रहा है.
इको बोल रहा है क्या है? हेलो, अभी भी आ
हाँ,
रहा है।
Yeah, I think we need to continue then. Yeah.
यस
yes.
यस।
Okay, cool. No echoes now. So what is the conclusion? Vote करें?
हाँ, मेरे ख्याल से दोनों बुक्स देख लेते हैं, एजेंट्स वाला मटेरियल देख लेते हैं और सिक्योरिटी वाला देख लेते हैं, उसके बाद वी कैन टेक ए कॉल। और एनीवे अभी हम नेक्स्ट वाले सेशन में इसी चैप्टर को कंप्लीट कर रहे हैं अंकुर, राइट?
Right.
हाँ सर, मतलब उतना है नहीं कंप्लीट करने को, बट या वी कैन कंटिन्यू और उसके बाद
हाँ, उसके बाद वी
we
कैन
can
टेक कॉल कि क्या करना है तो नेक्स्ट सेशन में। और टिल देन ये दो टॉपिक्स हैं, सिक्योरिटी, साइबर सिक्योरिटी एंड दिस एजेंटिक। इसके अलावा और कोई टॉपिक है वो भी आप लोग डाल सकते हो, और मयंक जी आप चाहो तो एक वोटिंग भी चला सकते हो उसमें। और क्योंकि काफी कम तो
हाँ शांतनु सर, अभी व्हाट्सएप पे चल रहा है, स्लैक कोई यूज नहीं कर रहा।
select
Oh, chapter 10 में क्या है? What is the subject?
AI आर्किटेक्चर।
Oh, ये architecture अच्छा रहेगा. I mean, is that not good or something, or people don't want that?
हाँ मतलब we should obviously cover this next chapter, but we can decide beforehand कि क्या पढ़ना है. So anyone who is interested can start reading. So
हाँ, chapter 10 finish करते हैं फिर.
like for me like cyber security like बिल्कुल कोई irrelevant kind of हो जाएगा, मतलब मेरे लिए तो फिर ऐसा है.
ठीक है, तो इसी पे रहते हैं, फिर एजेंटिक पे रहते हैं, और इसको चैप्टर 10 कवर करके वी कैन मूव टू एजेंटिक।
Yeah, yeah. Okay.
ठीक है अंकुर, आप अपना जो है एजेंटिक वाला भी स्टफ जरा यहाँ पे शेयर कर दीजिएगा, कोई बुक हो या कुछ।
श्योर सर, मैं थोड़ा सा मतलब मैंने भी मुझे कोई बुक एग्जैक्टली पता नहीं, तो मैं थोड़ा रिसर्च करके फिर शेयर करता हूँ 2-3 दिन में। हाँ, मैं ऐड कर दूंगा सर।
थैंक यू।
और मैं एडमिन नहीं हूँ सर, मैं आपको मैसेज कर दूंगा, आप ऐड कर देना।
I can, मतलब Slack, if people are still using, I can ask Bobby sir on that.
हाँ, मैं वही बोला, मैं आपको व्हाट्सएप पे डाल देता हूँ, आप सर को ऐड कर देना। ओके ओके, कूल देन, एंड हैप्पी लॉन्ग वीकेंड टू
सारी लोग के लिए तो लॉन्ग वीकेंड नहीं होगा।
या ओके, बाय बाय।
चलो, बाय एवरीवन।
Thanks everyone.
थैंक यू।